All right, so we are going to do the review for your mini test. So the bounded region shows for each problem represent the base of the solid, find the volume of each solid based on the given cross section, set up the integral first, and then use a calculator to evaluate. All right, so this one here we're having square cross sections. So the area of a square is s squared, s being the side, and we're perpendicular to the x-axis. So we are going to be in terms of x. Now I like to draw this little line across my shaded area so I can kind of see top, bottom. And since we're in terms of x, we're going to be using the x numbers. So we are going to say that the area is the integral from 0 to 3, because those are your intersection points there, and they're the x values. And then the side is going to be the top minus the bottom. So the square root of 3x plus 1 minus, and then the bottom function is x plus 1. Make sure you use parentheses. Now you don't have to simplify it, but sometimes it helps to simplify before typing in. So if you distribute that negative, that's going to become minus x, and then the plus 1 and the minus 1 are going to end up canceling. And remember, this whole guy here is being squared because s squared. So all of this right here is going to be squared. And when you type that in, you get 0.9. All right, so now we're going to do the exact same thing, except we're going to be perpendicular to the y-axis. So we're still talking about squares. So my area formula is still s squared, but instead of perpendicular to the x, we're perpendicular to the y. So we're going to go something kind of like this. We're going to use our y bounds, which is going to be from 1 to 4. And then right minus left. Now both of these guys I need to write in terms of y, so I need to make them as x equals. So this one here, I'm going to minus 1 and square it and then divide by 3. So x is going to equal y minus 1 squared over 3. And then this one here, I'm just going to minus 1. All right, so the right function is going to be y minus 1 minus, and then the left function is going to be this fraction right here, y minus 1 squared over 3. And then remember, all of that is being squared. I'm not going to mess with simplifying that because it kind of is more difficult than to just leave it alone. So I'm just going to leave it alone here and type in my equation, and I get 0.9. You do not always get the exact same thing, but in this case you do. Morning. Okay, so now I'm going to do square cross sections perpendicular to the x-axis of this shape. So still s squared for my side. X-axis is going to go like this. Now right here, we have to split. So at 2.2079, I need to split up my integral. So I'm going to say the integral from 0 to 2.2079. And then the top function is going to be ln of x. The bottom function is the axis, so it's going to be 0. So it's just going to be ln of x squared dx plus the integral from 2.2079. So that point right there all the way to 3. And then now the top function here is 3 minus x. And then remember, we're being squared because the formula for area. And then dx. And then when you type all of that in your calculator, you get about 0.469. All right, so set up the integral as part of my answer and type it in. Alrighty, now we're going to go same formula, s squared, but we're perpendicular to the y-axis. So my bounds are going to be from 0 to 0.7. Oh, wait, that's not from 0. That's from 1. Whoops. Mess up. 1. Yep. Silly me. All right, from 0 to 0.792. Now, when you're doing top and bottom function, the linear is going to be the right minus left. The linear is going to be the right, and then this ln is going to be the left. Now, we have to turn these into x equals. So to get rid of an ln, we're going to e. And then this one here, I'm going to add the x minus the y. So 3 minus y. Alrighty, so the right function is going to be 3 minus y minus, and then e to the y, all being squared, dy, which is going to be 1.1837. All right, number 5. A region is bounded by this guy and this guy as shown in the figure. The cross sections perpendicular to the x-axis are rectangles whose height is 5 times the width. So the area of a rectangle is height times width. And since the height is 5 times the width, then we can say the area of the rectangle is 5w squared. Okay, so because we are perpendicular to the x-axis, we're using x-bounds, which we have right here from 0 to 3, so we don't need to find them or anything like that. So we're going to say the integral from 0 to 3. I can move the 5 in the front. You don't have to, but sometimes it's easier to just kind of move those constants in the front. And then now we're going to do top minus bottom. So negative x squared plus 2x plus 3 minus, and then 2 minus x. Make sure you use parentheses, and then don't forget about your square. So then here is your integral. You could simplify that if you wanted to. That's not too bad to simplify. Distribute the negative. So you get negative x squared plus 3x plus 1 squared dx, which is going to be 100.5. Pen's written out. All right, next one. The base of a solid is the region bounded by that, and that. Cross sections are perpendicular to the y-axis, and once again, we've got a rectangle whose height is 3 times the width. So the area of the rectangle is going to be 3w squared. Same process from up here. So, and we're perpendicular to the y-axis, so we're going from here to here. My bounds are going to be from 0 to the y value, 1.3027. So I'm going to stick that 3 in the front. 0, 1.3027. And then right minus left. I do need to change these both to be x equals. So this is going to be x equals 3w, and this is going to be x equals y squared. So I've got 3 minus, did I say w? 3 minus y, not 3 minus w. 3 minus y minus y squared, all of it being squared, dy, which is about 15.4169. Okay, next page. All right, a region is bounded by that and that, as shown in the figure. Each cross section is perpendicular to the x-axis and is a rectangle whose height is 8. So the area of a rectangle is height times width, and if the height is 8, it's just going to be 8w. That's an H. That looks like a B. It's meant to be an H. All right, so for my area, and I'm perpendicular to the x-axis, so I need to figure out this intersection right here, which, just to save us a little time, you type it in your calculator, and it's going to give you 2.5 as that x value intersection. So I'm going to have the integral from 0 to 2.5. The 8 I can pull in the front. Now, w is not being squared, so we're just going to do top minus bottom. All right, and the top is 2, so 2 minus, and then your y function, 0.8 x to the 4th minus 2x cubed plus 2 dx, which your 2's are going to end up canceling, 2 minus 2. And so I'm just going to get 0, 2.5, negative 0.8 x to the 4th plus 2x cubed dx, which is going to be 77.5049. the region bounded by the y-axis, the graph y equals square root of x, the line y equals 4 is shown. The solid cross-section perpendicular to the y-axis, so we're in terms of y, is a rectangle whose height is 3. So your area of the rectangle is going to be 3, whatever the width is. So this 3 I can pull out in the front. Now we're going to use y values as my bounds. So I'm going to go from 0 to 4, and then right minus left. This guy here is the same thing as y squared equals x. If I solve that for x equals. So we are going to have y squared minus 0, because you're hitting the axis, squared dy. Oh, not being squared, because that's not being squared. Ooh, almost messed up. Again. So just y squared, because that's what w is. And when you type that in your calculator, you get 64. All right, and then number 9. Maybe this color it. All right, the graph y equals x squared minus x minus 3. Y equals x creates a bounded region that represents the base of the solid. Sections of the solid are perpendicular to the x-axis, form squares, so s squared. Find the volume of the solid. All right, so we're going to need a calculator because it does not give me my graph. And I'm going to type it in, x squared minus x minus 3 and x. And I'm going to hit graph. Okay, so this is my area right here. You're going to do the intersection to find your bounds, which, spoiler alert, are going to be -1 and 3. Since we are perpendicular to the x-axis, because we've got this shape right here, the top is going to be the linear, the bottom is going to be the quadratic. So x minus x squared minus x minus 3. All of that's being squared because the area formula, dx, which you could simplify if you want, but you do not have to because we're just typing this in and getting our answer. If you were having to solve it by hand, that's when you would definitely need to simplify. Alrighty. I think we're moving on from the squares and the rectangles to do some triangles and semicircles now. All right, the first one, we have an equilateral triangle, which is the square root of 3 over 4s squared, with the cross sections perpendicular to the x-axis. All right, so we are going to go from 0 to 2. I'm going to pull the square root of 3 over 4 out in the front, just because I kind of think it's easier when you have that constant out in the front. And then, since we're perpendicular to the x-axis, we're doing top and bottom. So the top is going to be 2 sine pi over 4x minus, and then the bottom, which is just x. All of that's being squared because of the formula dx, which is about 0.0788. Just be real careful when you're typing stuff in the calculator. All right, over here on number 2, semicircle, which is pi over 2 because it's semi, diameter over 2 squared. So pi r squared, but I write diameter over 2 to remind myself that I need to do top right minus left or top minus bottom. I have to divide that by 2 to get the radius. All right, so I'm going to put the pi over 2 out in front. Now my y bounds are going to be from 0 to 2. Then I have diameter right minus left. So remember, everything needs to be in terms of y. So we have to turn this into, so y is the linear minus, I have to turn this into x equals. So I'm going to divide by 2 first. Now to get rid of the sign, you're going to sign inverse. And then to get rid of the pi over 4, you're going to multiply by the reciprocal 4 over pi. And that's how you solve for x. So this is going to be 4 over pi sine inverse y over 2. Let's see. Close, 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 close. And it's being squared. Don't forget to divide all of that by 2. and dy. All right, so don't forget all of this in the squared. All of this whole fraction here is in that squared. So when you're typing it in, make sure it is all inside the parentheses. And you get 0.0, wow, go around that circle, 0.0715. All right, next one. Another semicircle, this time in terms of x. So pi over 2, diameter over 2, squared. All right, so in terms of x, I've got the square root of x and I've got the negative square root of x. So I'm going to put the pi over 2 out in the front. My bounds are going to go from 0 to 3. All right, and then I've got the top function, square root of x, minus the bottom function, negative square root of x. Double negative is a positive, divided by 2 squared dx. If you want to, this one isn't too bad to simplify a little bit, because square root of x plus square root of x is 2 square root of x, and then those 2's right there are going to cancel, which is going to give you just the square root of x squared. Which you could also cancel those guys, but I kind of ran out of space. So I'm just going to type it in now and get 7.0685. All right. All right, isosceles right triangle cross section. So isosceles right triangle is 1/2 base squared or side squared, whatever letter you want to use. We are perpendicular to the y-axis. So like that. Now this quadratic here as a y function is just y squared. All right, so when you solve both of these guys out, you get the exact same function. So I'm going to take my bounds. Oh, I need to figure out what these bounds are. So when you when you plug in 3 into that function, you get negative square root of 3 and positive square root of 3. So that's what your bounds are going to be. The 1/2 going to go in the front, negative square root of 3 to positive square root of 3. The right function is 3 minus the left function is y squared. And all of this is being squared because of the area formula, dy, which is 8.1318. Alrighty, number 5. All right, so we've got cross sections. Perpendicular to the x-axis are semicircles. All right, pi over 2, diameter over 2, squared. Set up the integral to find the volume, but do not evaluate. So all we have to do here is set up my integral. So I'm going to put the pi over 2 on the outside. Because we're in terms of x, we need to find our x numbers. So we are going from, it looks like, -3 to -1. And we are in terms of x, so I'm going to draw a little line here. The top function is going to be 3. The bottom function is going to be -1 over x squared. So double negative is going to turn positive. There might be some in that box, yeah. 1 over x squared. All of that's going to be divided by 2, and then squared. It just says set up the integral, so you don't have to simplify if you don't want to. And dx. All right, base is a solid, bounded by this and this. We are perpendicular to the y-axis, so we are going to have to turn this into x equals, so y squared over 4 equals x. And we have a nice isosceles right triangle, which is 1/2 base squared, side squared, whatever you want to use. Set up the integral to find the volume, but do not evaluate. All right, so 1/2 in the front. We are in terms of y, so we're going to go from 0 to 4. And then right minus left. So the right function is y squared over 4. Minus the left function, which is 0, and then all of that being squared dy. All right. Number 7. All right, so we are perpendicular to x. We have a semicircle, pi over 2, d over 2 squared. Set up the integral, find the volume of the solid. Do not evaluate. All right, so here's my line. We are going to go pi over 2 in the very, very front. The integral from 0 to 3. And then for your diameter, that's top minus bottom. So that's just going to be sine pi over 3 x minus 0. And then all of that's going to be divided by 2 squared dx. If you want, you could simplify this a little bit, but you do not have to, because it says just set up, but don't solve. Alrighty, the x-axis. All these functions, we are cross sections are perpendicular to the y-axis, so we're going this way. And we have an equilateral triangle, which is the square root of 3 over 4 side squared. Set up the integral, but do not evaluate. Okay, so since we are in terms of x, my bounds have to be, in terms of y, my bounds have to be y bounds. So we're going to be using the 1.3065. The square root of 3 over 4 is going to go in the front. And then I'm going to do right minus left. And now both of these have to be in terms of y. So e to the y equals x. And I feel like I did this one. Maybe I accidentally doubled up. Solve that one out. X equals 5 minus y. So the right is going to be the linear. So 5 minus y minus e to the y. And then all of that's being squared dy. Alrighty. And last one on this page. I've got x squared minus 4, 4 minus 2x creates a bounded region that represents the base of the solid. The cross sections are perpendicular to the x-axis and are semicircles again. So pi over 2, diameter divided by 2, squared. Set up the integral, but do not evaluate. All right, so if you want to graph this, although this one might be a non-calculator because these are pretty easy to graph. This one's going down 4, and it's happy face. And this one here has a intercept at 4 and a negative slope. So it's going to go something like this. The cross sections are perpendicular to the x-axis. So my cross sections are going this way. And we're going to find our bounds first. So x squared minus 4. If you don't have your bounds, you have to set them equal to each other to find your bounds. If you have a squared, move everything to one side. So x squared plus 2x minus 8 equals 0. X plus 4, x minus 2. So my bounds are going to be negative 4 and 2. All right, so pi over 2 in the front, negative 4, 2. And then I'm going to do the diameter, which is top minus bottom. And we're perpendicular to the x, so these are all good how they are. So 4 minus 2x minus, and then x squared minus 4, all divided by 2 squared dx. Okay. Next ones. All right, now I think we're going to start revolving. So for each problem, sketch the area bounded by the equation and revolve it around the x-axis. Find the volume of the solid formed by this revolution and leave your answer in terms of pi. So I've got 2x squared, y equals 0, and x equals 2. So we've got this region right here. And we're going around the x-axis. So I'm going to draw my little line so I can see my radius. from your axis of revolution to the outside function. I'm going to put the pi in the front, pi r squared. My bounds are going to be from 0 to 2, and then the top function, which is 2x squared, minus the bottom function, which is 0 squared dx. And when you type that in, you get 128 over 5 pi. So remember, if you want to leave this in terms of pi, just don't type pi in, and then you'll just put it in your answer in the end. This looks like a 6, but it's actually a 0. I don't know if that made it better or worse. All right, next one, 4 minus x. So 4x-intercept, I'm sorry, y-intercept is 4, and it's got a negative slope. And then we've got x and y equaling 0. So we've got this little triangle right here. And once again, we are going around the x-axis. That's my axis of revolution. So if this is 4, then this is also going to be 4 because of the negative slope. It's a -1. So my bounds are going to be from 0 to 4. Pi is going to go on the outside, and then your radius is going to be 4 minus x minus 0, and then squared dx, which is going to give you 64 over 3 pi. All right, same instructions as above, but use a calculator and round to 3 decimals. Sweet. All right, so I've got x equals x cubed, which looks kind of something like that, y equals 0, and x equals 3. So this is my region here that I'm revolving. And we're still revolving it around the x-axis. So pi integral from 0 to 3. The top function is x cubed squared pi r squared and dx, which is going to give you 981.523 when you type that in the calculator. Alrighty, next one. Let's type this in just to make sure we know what it looks like, because these are always kind of weird looking. So the square root of 4 minus x squared. Yep, looks kind of like that. And we're just talking about quadrant 1. So we're just talking about this little part right here. All right, so we're up here at 2. This is also at 2. So we are going to go pi r squared, the integral from 0 to 2, and we're still revolving around the x-axis. The top function is going to be the square root of 4 minus x squared being squared. So those are going to end up canceling. So you could also write it as just 4 minus x squared dx, which is going to be 16.755. All right, same instructions as above, but revolve around the y-axis now. Leave your answer in terms of pi. All right, 2x squared, y equals 2. We're revolving around the y-axis now, so everything needs to be in terms of y. This is my region I'm revolving. So pi, my bounds are going to be from 0 to 2, because this is all the way up here at 2. Now, that function here, we're going to divide by 2, and then we're going to square root. Every time you square root, you should plus or minus, but this one here, because it's the right side, is going to be the positive. So when I'm doing my radius, right minus left, the left is the axis, which is 0. So I've got the square root of y over 2 squared dy, which squared and squared will end up canceling. And so just y over 2 dy, which when you integrate is going to give you pi. All right. Y-intercept is up here at 3, negative slope, going something like this. X equals 0, y equals 0. All right, so there's my bounded area. We're in terms of y. So we're revolving this way. So I need to write this guy in terms of y. All right, so first I'm going to minus the 3. And then I'm going to times by -6. So -6y plus 18 equals x. All right, so pi integral 0 to 3, the right function is going to be -6y plus 18 minus 0, which is the axis, squared dy, which is going to give you 324 pi. Moving on. All right, so now I think we are revolving around other lines. Still going to be this method though. Alrighty, 3 minus x squared, so that's going to go something kind of like this. Up here at 3, y equals -1, that's right here. And we're revolving around that line, y equals -1. So the bounded area is that shaded area right there. Draw my line for the radius. We are revolving this way. My radius is perpendicular to the x, so everything is going to be in terms of x. So we do need to figure out these intersection bounds right here. So 3 minus x squared equals -1. Minus 3, lose the negative, and so you get positive and -2. So for my volume, I've got the integral, pi in the front, -2 to 2, and the top function, which is 3 minus x squared, minus the bottom function, which is -1, so double negative turns positive, which you could add up the 3 and the 1 if you wanted to simplify before you typed it in, to 4 minus x squared dx, which is, oh wait, we don't have to type it in. Set up but don't evaluate. Whoop. All right, number 2, x equals y squared plus 3, and x equals 1. All right, let's see, x equals 1 is right here, I know that. Y equals -2 is right here, and y equals 1 is right here. Now, y squared plus 3, if it helps, especially if you didn't have a calculator to solve this for y, so -3 and then square root, you can kind of see more about what the transformations are going to be like. And remember, when you square root, you have to plus minus. So this is really moving to the right 3. So 1, 2, 3. And it is the square root function. So it's going to go something like this. This is kind of a weird one. All right, so the area that's bounded by all of these things is right here. And we are going around the line. X equals 1. All right, so we're in terms of y because my radius is right here. And you're revolving this way, which helps that this guy is actually in terms of y. Now for my bounds, I'm going to go from -1 to 2. So these guys here really are just going to end up being my bounds. All right, or -2 to 1. All right, so -2 to 1. And then the right radius is y squared plus 3. Or not the right function. The right function is y squared plus 3. The left function is going to be just 1 squared dy. And you could combine those if you wanted to make that a 2. You don't have to, though, especially if it's for response. But if it was multiple choice, they'd probably have it combined. All right. X equals the square root of y. So same thing. That's the same thing as y equals x squared. And then we have y equals 4, x equals -1. So this is going to be -2. So x equals -1 is going to be like right here. So many lines. And then y equals 1. About the line x equals -1. So we're revolving this way. All right, so I'm going to highlight my little area. So that's my area right there that I'm revolving around. Oh wait, is it? Hold on, pause. No, because I want the right side. This is the negative. Ah, I messed up. Okay, I don't want this side because that's the negative version and I only have the positive square root. And that makes things a little easier. Less stuff going on. All right, there we go. So for my radius, it is going to be right minus left. My bounds are going to be from 1 to 4. So pi 1 to 4. And then the right is going to be the square root of y minus the left, which is going to be -1. All of that being squared dy. Should have drawn my picture bigger. All right, let's do 4. All right, so this is the square root function. That's getting moved up 1, whoop, something like that. Y equals 1, which is right here. And x equals 4, which is right here. And we're going about the line y equals 1. So that's my axis of revolution right there. So this is my shaded area. My radius from my axis of revolution to the outside is right here. So that's my R. So pi integral from 0 to 4, the top function, which is the square root of x plus 1, minus the bottom function, which is 1, squared dx, which those 1's will cancel, and the square root and the square will end up canceling as well. So you really just have pi integral from 0 to 4 of x dx, if you simplified. Okay. All right, another one in terms of y. So, -3, and then if you, negative y squared, minus the negative, so you get y equals the square root of 3 minus x, plus or minus. Alrighty. So, transformation-wise, what's happening here? This one's kind of weird. Is we're going to move right 3, and we are reflecting over the y-axis, so we're going to be pointed this way. So we're going to move to the right 3, 1, 2, 3, but we're going to point this way with my parabola. All right, then I have x equals 2, which is right here, and we are rotating about this line, x equals 2. So this is my shaded area, which I don't know if it's easier to solve or if it's easier just to turn your paper and go, okay, we're moving up 3 and we are flipping and making it negative. So, I don't know. Whichever way is easier. All right, anyways. We are in terms of y, so we need to figure out the bounds. 3 minus y squared equals 2. Minus 3, which is -1. All right, so plus minus 1. So my integral is going to be pi -1 to 1, and then we are going this way. So this guy right here is my radius. So the right function, which is going to be the 3 minus y squared, minus the left function, which is going to be x equals 2 squared dy, and you could combine the 3 and the -2 to make that +1 if you wanted. All right, how much more do I have? I gotta be getting close, right? All right, up to quadratic y equals 2. Oh wait, shoot, I drew that in the wrong spot. Y equals 2, x equals 2, and about the line, y equals 2. So around this line right here. So my little region that's getting bounded is this little guy right here, and we're rotating it this way. So this is my little r. We are going in terms of x because we're perpendicular to the x. So pi from 0 to 2 of the function on top, which is x squared plus 2, minus the function on bottom, which is 2 squared dx. These 2's are going to end up canceling. So you could make that into this integral. What's up?
Hey.
Hey. Congratulations.
Thanks. There's leftover treats in the teacher's lounge. Cupcakes
Awesome.
and Rice Krispie treats and things like that. So.
It's a girl. Are you excited?
Yeah, I'm so excited. I was like, I wanted a boy. I've always wanted a boy first because I was like, I want an older boy to like.
Yeah.
Take care of everybody else, but I also only know girls. Like, you know, I only have sisters, and I think I'll actually know what I'm doing a little more than with the boy.
Yeah.
So.
That is so exciting. And I like your name. You know, my best friend's daughter's name is Chloe too. So
That's hilarious. Yeah, and I think Michelle Peacock's daughter is literally named Chloe Ann.
yeah.
I was like, well, we really like it. So.
It's still cute. Yep.
Well, anyway, free treats if you want one.
Awesome. Thank you.
Uh-huh.
All right. 2 pages left. For each problem, sketch the area bounded by the equation, revolve it around the x-axis, find the volume. My calculator's allowed. Sweet. Okay. So these are probably the washer method ones. All right, so we're going to go up to 4 and the sad face parabola. And then we also have 2 and negative x, so something kind of like this. And we're going to revolve this around the x-axis. So big R is right here, little r is right here. So the big R is going to be 4 minus x squared minus 0, and little r is going to be just 2 minus x minus 0. So when I write this as a integral, pi from, I need to figure out my bounds. All right, so when I set these equal to each other, 4 minus x squared equals 2 minus x. So I'm going to move everything to one side. So I'm going to add the x squared and, minus the x and minus the 4. So 2 minus 4, which is going to be negative 2. So x minus 2, x plus 1. So my bounds are going to be negative 2, or 2 and negative 1. So negative 1. So this is going to be negative 1, and then that's going to be 2. All right, so pi negative 1 to 2, big R squared, so 4 minus x squared squared minus little r squared, 2 minus x squared, dx. Type that in your calculator, and you get 67.858. All right, so this is another one. This is the same equation as this guy right here. So this is what the graph is going to look like. Whoop. So right here at 3, and then x equals 2, and we're going to revolve this around the y-axis. So this is my shaded area. And I've got big R and I've got little r. So big R is going to be 3 minus y squared minus 0 because of the axis, and little r is just going to be 2. So pi, and then my bounds, all right, so I'm going to set these guys equal to each other. 2 equals 3 minus y squared minus 3, which is going to be negative 1 equals negative y squared. So your bounds are going to be positive 1 and negative 1. So negative 1 to 1. 3 minus y squared minus, and then 2 squared dy, which when you type in is going to give you 20.106. Alrighty. This guy here is getting shifted right 3, 1, 2, 3, 1, 2, 3, 4, 5, and down 5, and it's facing upward. Whoop. And then y equals negative 1. So that's your bounded area here. And we're revolving this around the x-axis. So big R and little r. And I'm going to have to figure out my bounds. So negative 1 equals x minus 3 squared minus 5, 4 square root, and you get plus or minus 2. So positive 2 plus 3 is 5, and negative 2 plus 3 is 1. So my bounds are going to be 1 and 5. All right, big R. So top is going to be 0 minus, the bottom is going to be x minus 3 squared minus 5. Don't forget about your parentheses here. And little r is going to be 0 minus, and then negative 1. So when I write this guy, the volume from 1 to 5 is going to be negative x minus 3 squared plus 5, because I distributed this negative, squared minus, and then little r, which is just going to be 1 squared, dx, which when you type in is going to give you 174.2536. Okay, same region as 3, but revolve it around the y-axis. Blech. All right, so for the y-axis, I know this guy's going down to negative 5, and then this line here is going to be at negative 1, so I don't have to find my bounds. That's the nice thing. Now this is going to be big R, and that's going to be little r. All right, so big R, we have to solve these. Ugh. All right, y plus 5 equals x minus 3 squared, square root with a plus or minus equals x minus 3. So x is going to equal 3 plus or minus the square root of y plus 5. All right, perfect. So big R is going to be the positive side, so 3 plus the square root of y plus 3, and little r is going to be the negative side, so 3 minus the square root of...
Hello. Good morning.
Hello.
Doing math early in the morning.
Doing math. So my integral is going to be from negative 5 to negative 1. Big R squared minus little r squared. 3 plus square root y plus 5 squared minus...
There's a lot of ways you can do that math.
Yep. 3 minus y plus 5 squared dy, which when you type in your calculator is going to be 201.0619.
How can you not this hard math?
I do. 1 page left.
I need some coffee today.
I cannot help you with that. I don't have coffee.
And I wish you had a coffee pot here so we can start making coffee.
Mr. Stallbite.
Oh, nice.
Okay. Last page. A region S is bounded by x squared and y equals 2x. Those are at least nice functions. And 2x, which is going to go something like this. So we've got this region right here. Sketch the graph and find the area. So area is going to be just the integral of the top function minus the bottom function. So we got to figure out our bounds, which are going to be from 0 equals 2x to 2. All right, so the area is going to be from 0 to 2, top function, which is 2x minus x squared, dx, which is going to be 1.333. All right, now we're going to let S be the base with cross sections perpendicular to the x-axis that form a semicircle. So pi over 2, d over 2 squared. All right, so pi over 2, my bounds are still going to be from 0 to 2. My function is still going to be top minus bottom. The only difference, though, is we have to divide this by 2 and then square it because of the area formula, which is going to give you 0.41887. All right, let S be the base of the solid with cross sections perpendicular to the y-axis. And it forms isosceles right triangles, which is 1/2 base squared or 1/2 side squared. All right, so these guys here we need to rewrite. So this is going to be x equals plus or minus the square root of y, and x equals y divided by 2. And so we are perpendicular to the y-axis, which my bounds are going to be from 0 still. 2 up here is going to be at 4. When you plug 2 in, you get 4. All right, 1/2 in the front, 0 to 4, the right function, which is going to be the square root of y, minus the left function, which is going to be y over 2. All of that being squared, dy, which is 0.2666. All right, and then now we're going to talk about our revolving. Write the equation for big radius and little radius. For the solid revolution when revolving around the given line, set up the integral to find the volume of the solid. Do not evaluate. All right, so I'm going to redraw my picture over here. So this is, of course, at 0. This is at 2. This is at 4. And then I've got y equals x squared, or the square root of y equals x. And then I also have y equals 2x, or y over 2 equals x. All right, I think I'm good. Since we're going around the line, y equals 4 for the first one, that's right here. So big radius is going to be, the top is going to be 4 minus, oh, and you're perpendicular to the x, so we're good with staying in x. So 4 minus x squared. Little radius is going to be 4 minus 2x. And so then the volume, pi, the integral from 0 to 2, 4 minus x squared squared minus 4 minus 2x squared dx. All right, next one. Around the line x equals 2. So now we're talking about this line. All right, so from my axis of revolution to the outside and then to the inside. So the big radius, right minus left, is going to be 2 minus, and then the linear y over 2. And then little radius is going to be 2 minus, and then the quadratic, which is going to be the square root of y, and we're in terms of y on this one. So my bounds are going to be from 0 to 4, big radius, 2 minus y over 2 squared, minus little radius, 2 minus the square root of y squared, dy. And then my last one. All right, around the line, x equals -1. So right here is -1. All right, we're in terms of y again. So from my axis to the outside, from my axis to the inside. Because we're in terms of y, we're going to stay from the bounds of 0 to 4. So big radius is going to be the right function, which is the square root of y, minus the left function, which is -1. So double negative turns positive. And then for little radius, we are going to go right function, which is y over 2, minus left function, which is going to turn positive, square root of y plus 1 squared minus y over 2 plus 1 squared dy. And we're done with the review.